Hello, everybody. Today we're doing the next problem in the Landau Lifshitz textbook series for mechanics. This is chapter 1. I'm doing question number 2. In this question, we are finding the Lagrangian for a pendulum with a sliding support. So we're going to start by drawing a diagram with a horizontal line representing the path along which the support can slide. The support has a mass of m1, and the end of the pendulum has a mass of m2, and the length of the pendulum is L. We can represent the system with two variables, phi and x. And just like in the last problem, we're going to list out all of our coordinates, and then we're going to convert those coordinates into the more familiar Cartesian coordinates. Before we move on, we're going to express the kinetic energy in terms of the Cartesian coordinates, because that's the simplest way to do it. And then we are going to convert from those Cartesian coordinates to the desired coordinates using our coordinate transformations. So we'll start writing our coordinate transformations. First ones are simple because the sliding support is moving within the Cartesian coordinates. However, the end of the pendulum is moving with an offset. So its position is slightly more complicated. This time around, I'm calculating the time derivatives of each coordinate as I go, and we will use those in the next step. Now we're going to take our expression for the kinetic energy and substitute in our expressions using our coordinate transformations, and then we will simplify. With our initial expression, we can start simplifying, and the first step is to take out the x dot squared term from the right term and insert it into the first. Now I'm expressing the term that comes from the L squared cosine squared phi times phi dot squared plus L squared sine squared phi times phi dot squared, in which the sine and the cosine cancel out. And we're left with final cross term m2L cosine phi times phi dot times x dot. Now we can start expressing potential energy, which in this case is fairly straightforward. With the potential energy and the kinetic energy, we can express Lagrangian just by filling in our previous results. And this is the end of this problem. I'll be back soon with the next problem.